Alrighty, calculus students, we are on chapter 5.4, and today's lesson is actually kind of a review of two different things that you've learned before. So we're going to focus on indefinite integrals and definite integrals. So indefinite integrals looks like what you just learned in the previous lesson, which is definite integrals, except that you don't have any limits of integration, which means that you work these exactly as you would as though you were finding an antiderivative, but we don't have to evaluate it at all. So what we're going to do for each of these questions is we're actually looking at the derivative of something and we're finding what its antiderivative is. And because we don't have any limits of integration and we're not evaluating at constant numbers, we need to make sure that we always include our plus c at the end. Okay, so our first example is a polynomial, and that means we're going to reverse our power rule. Reversing our power rule means we are going to bump up our power from 4 to 5, and then divide by that power of 5. On the next term, I have a coefficient of 2. That 2 just carries down. I'm going to bump up my power to 4, divide by 4. And then the last one, I'm going to bump up my power to 2, divide by 2. And this is an indefinite integral. Indefinite integrals always need a plus c at the end. And really the only thing you could do to clean this up a little bit is I can simplify that fraction here. So that would be x to the 4th over 2 minus 5x squared over 2 plus c. Okay, and looking at example number 2, let's see if I can clean this up a little bit. There we go, a little bit sharper of an image. On example number 2, we've got some trig expressions. So for the first expression, sine is the derivative of what? It is the derivative of cosine, and we have an operation change. So the antiderivative of sine would be negative cosine of x. For the next term, the coefficient carries down, just like it did on the last example where the 2 carried down. And cosine is the derivative of sine, therefore cosine's antiderivative is sine of x. And we're going to include our plus c. If you forgot all of your antiderivatives, you can go back through our notes, or you can look at chapter 5.3, 5.4 notes on the focus resources. Or you can always go to your green sheet, which has derivatives, and then you're just reversing the process of your derivatives. If you have your green sheet at home, some of you guys might have left those in your lockers. Okay, for number 3, we have secant squared. Well, secant squared is the derivative of tangent of x. And then we'll include our plus c. And then for the last one, that is not written in the form of a polynomial. It's written in a squared form, and I do not know how to reverse a power rule in this form. So what I want to do is expand this out first. So I'm going to do a rewrite. So if I were to multiply out 2x minus 3 times 2x minus 3, I would have 4x squared minus 6x, and minus 6x is minus 12x plus 9. And now I'm going to find my antiderivative. So carry down your 4, bump up your power to 3, divide by 3. Carry down your 12, bump up your power to 2, divide by 2. And then your 9 picks up an x, so plus 9x plus c. And I'm just going to go one more step, and I'm going to clean that up a little bit. So we've got 4x cubed over 3 minus 6x squared plus 9x plus c. All right, so now you've seen 4 examples of indefinite integrals. It's basically what you did at the end of chapter 4, which is finding an antiderivative, and don't forget your plus c. So you saw an example of a polynomial that you had to expand out first, and then 2 trig examples. All right, the last thing we're going to look at today are definite integrals. And you guys have seen these before. You did this in the last unit in chapter 5.3. So we're just kind of reinforcing what you learned in 5.3. On example number 5, now I'm seeing that I have limits, so I need to find my antiderivative, and then I'm going to evaluate at 3, evaluate at 0, and then take the difference between those two. So I need to rewrite this so that I can reverse my power rule. So I'm going to distribute this. So x times x is x squared. X times 1 is x dx. And now I am ready to evaluate, find my antiderivative first, and then evaluate using the fundamental theorem of calculus. All right, so we're going to bump up our power. X cubed over 3 plus x squared over 2. And if you put your plus c on there, once we evaluate, the c's always cancel, so I'm just going to skip that plus c. So you have to have the plus c in the indefinite integrals, but it is really optional for the definite integrals. And we're going to evaluate from 0 to 3. So now we're going to find the antiderivative at 3 minus the antiderivative evaluated at 0. So I'm going to substitute this in first. So we'll have 3 cubed over 3 plus 3 squared over 2 minus 0 cubed over 3 plus 0 squared over 2. So that's 27 over 3, which is 9. And that is plus 9 halves minus 0. Those are all going to zero out. So we have 9 plus 4.5, or if you want to find a common denominator, you can do it that way too. So we would have 18 plus 9. So 18 plus 9 is going to give us 27 over 2. Okay. Oh, you can't see that. Let's just scoot that up a little bit. All right, so now you saw kind of a refresher example of a definite integral, and I'm going to do one last one with a trig expression because you didn't see one of those in the last video that you watched in chapter 5.3. So we're going to start with the antiderivative of sine of x, which would be negative cosine of x. Again, this is a definite integral because it is bound by numbers. We have limits of integration. We're going to evaluate from 0 to pi over 2. And I'm going to substitute pi over 2 in. And then I'm going to substitute 0 in. And my pen's dying, so hang on a second. Okay. So we're going to evaluate negative cosine of pi over 2. All right, so you have a calculator at home, so you're welcome to use that, or you can just think about your unit circle. If we are up here at pi over 2, we're looking at the point 0, 1, and so cosine would be 0. And then for our second term, we've got cosine of 0, so that would be my point over here on the right at 1, 0, and my cosine value would be 1. I don't know why I started to write that there. This would be 1. So we have 0 minus 1 or negative 1. Just a word of caution, sometimes people tend to get lazy and assume that whenever you substitute a 0 in, things zero out. That happens with x terms, with like polynomial terms. That does not happen all the time with trig expressions. And here is a perfect example because cosine of 0 is not 0, cosine of 0 is 1. All right, so you should be all set. That was just a nice little review of definite integrals and then the introduction of the new indefinite integral notation for antiderivatives. Okay, thanks for listening.